Hi everyone, so this video is going to be about problem solving with Venn diagrams. So this is one of my favorite topics. I love doing problems with Venn diagrams, and I promise you that even if these initially seem a little complicated, they will feel easier later. I promise. It happens every year. So we're going to go through three examples, three sort of different takes on problem solving with Venns. So this first example is when the Venn diagram is presented with the problem. So when you're just asked to gather the information to answer the questions from the Venn diagram that's already been created for you. So I would say this is like the easiest type of Venn diagram problems. So we've got Venn diagram alongside illustrates the number of people at a sporting club who play tennis and hockey, represented by T and H. Determine the number of people in the club. So to determine the number of people in the club, we're going to add up all of the numbers that exist in the Venn diagram. So we've got 15 plus 27 plus 26 plus 7. So that gives us a final answer of 75. So we have 75 people in the club. So part B, determine the number who play hockey. So hockey is represented by this H circle here. So everyone that exists in that circle plays hockey. So that's 27 people plus 26 people to give us a total of 53 people. Part C. Determine the number of people who play both sports. So to play both sports, you must be in the middle, because you have to be inside this tennis circle, but you also have to be inside the hockey circle. So only the 27 people that are in the very center of the Venn diagram play both sports. D, the number of people who play neither sport. So neither sport exists outside of the circles, because if you play a sport, you're going to be in the circle. If you don't play a sport, you're outside the circle. So that leaves us with 7 people who play neither sport. And then the last one, play at least one sport. So with these questions, you have to really pay attention to the wording. At least one. That means they could play one or they could play both. So these 15 people play one. These 26 people play one. These 27 people play 2, which is at least 1. So add that all up to give us a total of 68 people who play at least one sport. Okay, so that's an example of when the Venn diagram is already given to us. So let's look at 2 examples where we have to both construct the Venn diagram and then answer some questions about it following. So again, key words here are crucial. So let's read through the scenario here. Class of 30 students, 19 take physics, 17 study chemistry, 15 study both of these subjects. Display this information on a Venn diagram and hence determine the number of students who study, and then we're given a bunch of specific cases. So we always start with our Venn diagram. So when you are constructing a Venn diagram based on 2 groups, in this case we're going to label them physics and chemistry, P and C, and then our universal set is on the outside. We have 4 places where we need to put a number. And there is always going to be some information in the question that tells you where to begin. You are always going to start with either the outside number or the number in the center. So you're looking for keywords such as neither or both. So in this, we have this little word up here, both, and we know that 15 study both. So because we know that 15 study both, that is the first number we're going to put in. So we've got 15 people placed inside our both circle. So then we're going to go to either this 19 who study physics or this 17 who study chemistry. It's up to you which part you want to start with. Let's start with physics. So if 19 people study physics, that means that in my physics circle, I must have 19 people. I already have 15 people in that circle. So that leaves me with 4 slots for people who study only physics. Similarly, if 17 study chemistry, that means that in the chemistry circle, I must account for 17 people. There are already 15 people in that circle. So that means I have 2 spots left to put people into the chemistry circle. So then the last number I have to fill in this case is my outside number. How many students don't study either of these subjects? We have 30 students altogether. We have already accounted for 4 plus 15 plus 2. So we have accounted for 21 students. That means 30 minus 21, who are already accounted for. There are 9 students remaining. So those 9 students go on the outside. They don't study either physics or chemistry. So now that we have our Venn diagram constructed, we're going to answer the questions. So first question, how many students study both subjects? So both is that center number, so that's 15 students. B, how many study at least one? So at least one means they have to be in the circles. So 4 plus 15 plus 2. So that gives us a total of 21 students studying at least one subject. C, how many study physics but not chemistry? So that means they're in the physics circle, but they can't be in the chemistry circle. So that means that it's these people here. So that means 4 students studying physics but not chemistry. How many are studying exactly one of the subjects? So that means they're inside the circles, but they're not in both of them. So we've got the 4 people who study just physics plus the 2 people who just study chemistry. So 6 students study exactly one. And then final question, how many study neither? So that's the outside number. So 9 students study neither. So there's sort of a stereotypical example of how to navigate through a Venn diagram when the key word provided in the question is both. Okay, last example we're going to go through. Class of 40 students. 19 play tennis, 20 play netball, 8 play neither. Determine the number of students in the class who. So we're going to start with a Venn diagram. Even though this question doesn't ask us to, most will. So again, we have 4 spots to fill in. So we've got our universal set, and we'll put T for tennis and N for netball. It is really important that you label your circles in your Venn diagram so that whoever is coming after you understands the work that you have done. So we're going to start with this neither situation. So 8 study neither. So that means 8 are going on the outside. So out of our 40 students, we have now accounted for 8 of them, leaving us with 32 students to put somewhere into this Venn diagram. The problem is that the number we have left here, 19 tennis players, 20 netball players, that's more than 32. So if we add up the people from the question that are playing the 2 sports, that's 39. How do we account for 39 people when we only have 32 left to put somewhere? So the difference between those 2 numbers, the difference between how many people the question says we have left and how many people we actually have left, that's our overlap number. So that number goes in the center. So we have 7 people that are playing both because the question says we have 39 left to put somewhere and we only have 32 left to put somewhere. So the difference between those are the people who play both. Then after you've done that, filling in the rest of the circles is exactly the same as we did it in the previous question. So if there are 19 people playing tennis, that means we have to have 19 people in the tennis circle. There are already 7 people there, so that leaves 12 for the outside. We have 20 people playing netball, so that means 20 people must go in the netball circle. There are already 7 there, so that leaves us with 13 more people to put in. Do yourself a favor. before you get to the questions, just do a quick calculation. Add up all of your numbers. Make sure you get the number of people that you should get. So if I add 12 plus 7 plus 13 plus 8, I get 40. So, I mean, it's not a guarantee that I've put the numbers all in the right place, but at least it's a little check. So now we head over to the questions. So question number 1, how many people play tennis? The question gave us that. We didn't even need a Venn diagram for that. There are 19 people who play tennis. We could have used our Venn diagram and added our 12 people plus our 7 people. Part B, how many do not play netball? So that means everybody that is not in the netball circle. So there are 12 people in the tennis circle. There are 8 people on the outside. So that means there are 20 people who do not play netball. Or you could have just said, the question told us 20 in a class of 40. So that leaves 20 that don't play netball. C, play at least one of the sports. So again, at least one means they're in the circle somewhere. So at least one means our 12 plus our 7 plus our 13 to give us a total of 32. Or you could have looked at it too, 40 students, 8 don't play any, right? So there's lots of different ways you could sort of arrive at the final answer of 32. D, play one and only one of the sports. So that's looking at just the people who are not overlapping in the circles. So one and only one is going to be our 12 who play tennis, our 13 who play netball. So that gives us 25 who play one and only one. And then last part of the question, how many people play netball but not tennis? So they're in the netball circle, but they're not in the tennis circle. So that's only the 13 on the outside. Okay, and that sort of wraps up 3 examples of how to use Venn diagrams to solve word problems.